March 1943. The pale winter light filtered through the windows of the Royal Aircraft Establishment Laboratory, Farnborough. Dr. William Harrington hunched over his workbench, his tweed jacket dusted with chemical residue, his eyes red-rimmed from too many sleepless nights. Before him lay a peculiar cylindrical canister, recovered from a downed Messerschmitt Bf-109G, one of the Luftwaffe's high-altitude interceptors shot down over the Channel 2 weeks prior. It was part of the German oxygen system, but its exact function remained elusive. The components didn't match anything in British or American aircraft. For weeks now, RAF pilots had reported mysterious incidents of unconsciousness at high altitudes despite functioning oxygen equipment. Some never returned to tell their tales. Intelligence officers had been collecting fragments of Luftwaffe aircraft, searching for any technological edge that might explain the Germans' ability to operate effectively above 30,000 feet. This canister, intact and bearing manufacturer markings from the Draeger Company of Lübeck, was their most promising find yet. Across the room, Dr. Margaret Fleming carefully recorded readings from a modified altitude chamber where various components of captured Luftwaffe breathing apparatus were being tested. Her dark hair was pulled back in a practical bun, a lab coat buttoned high against the perpetual chill of the English spring. An Oxford-trained chemist, he had abandoned a promising academic career when war broke out to join the scientific effort against Hitler. "William, look at these readings," she called, waving a sheet of graph paper. "The carbon dioxide levels are fluctuating in patterns I can't explain. It doesn't match any absorption system we've ever encountered." Harrington crossed the room, took the paper, and studied it with intensity. "It's as if the system is selectively filtering certain gases, but then failing at specific intervals," he muttered, his mind already racing through possible explanations. And those intervals correspond precisely with the reported blackout incidents. Outside, the rumble of bomber formations heading east toward Germany provided a constant reminder of what was at stake. For every scientific breakthrough here, lives would be saved over the skies of Europe. Meanwhile, over the freezing skies of eastern Prussia, Hauptmann Karl Weber of Jagdgeschwader 51 guided his Messerschmitt Bf-109G through the thin air at 33,000 feet. The fighter vibrated around him as he scanned the horizon for the telltale silhouettes of Allied bombers. His breath fogged inside his oxygen mask, the rubber cold against his face despite the electrical heating elements. After 3 years of combat on the Eastern Front against the Soviets, Weber had been transferred west to help defend the Reich against the increasing Allied bombing campaign. The bitter cold at this altitude was familiar to him after the Russian winter, but the oxygen systems were different from the ones he had used in his earlier Bf-109F. The new equipment allowed the Luftwaffe fighters to climb higher than before, intercepting the American bombers before they reached their targets. But there had been incidents, unexplained losses. Pilots who were experienced, who knew how to handle their aircraft in the thin air, simply disappeared or were found slumped in their cockpits, having seemingly fallen asleep mid-flight. Weber checked his oxygen flow indicator, a small metal wheel that spun to show that the life-giving gas was flowing properly through his mask. All appeared normal, but he felt a slight headache beginning behind his eyes. He had been briefed about the importance of checking this indicator frequently, more so than in his previous deployments. The ground crews had been especially insistent about changing the chemical canisters in the oxygen system after each mission, though they never explained exactly why. Looking down, Weber could see the patchwork landscape of occupied Europe, thousands of feet below, farms and villages reduced to miniature by distance. Somewhere down there, scientists were working to give the Luftwaffe every advantage in the increasingly desperate air war. What he didn't know was that far to the west, their British counterparts were working just as diligently to counter those advantages. Back at Farnborough, Harrington carefully cut open the mysterious German canister. Inside were tightly packed pellets of an unfamiliar chemical compound. He extracted one with tweezers and dropped it into a test tube where it fizzed slightly upon contact with the solution he had prepared. "Potassium superoxide," he murmured, recognizing the reaction. "But there's something else mixed in, something I haven't seen before." Fleming leaned over his shoulder, a scientific curiosity piqued. "The Germans are using potassium superoxide as an oxygen generator," he asked, surprise evident in her voice. "That's remarkably advanced. When it reacts with moisture and carbon dioxide, it releases pure oxygen while absorbing the CO2. A closed-circuit system would be much more efficient than our constant flow design." Harrington nodded, already scribbling calculations. "It would extend their operational ceiling significantly. Their pilots could stay at high altitude much longer than ours with the same amount of oxygen supply. but that doesn't explain the blackouts. The two scientists worked through the night, testing samples in the altitude chamber, replicating the conditions of high-altitude flight. By dawn, Fleming's eyes widened as she watched the carbon dioxide detector spike suddenly. "William, I think I've found it," said. Her voice hushed with the gravity of discovery. "The chemical matrix of these pellets breaks down after extended exposure to moisture. When it does, it stops absorbing carbon dioxide and begins to release what it's already absorbed. The pilots aren't running out of oxygen, they're being poisoned by their own exhaled carbon dioxide." Harrington quickly confirmed her findings, running a series of tests that showed how the pellets would work perfectly for the first hour or two of flight, then catastrophically fail if not replaced. "The Germans must not have discovered this flaw," he said, "or they haven't found a solution. Their pilots are using a system that turns deadly without warning. No wonder they've been losing aircraft without apparent cause." Oberstleutnant Heinrich Krüger strode through the laboratories of the Trägerwerk facility in Lübeck, his Luftwaffe uniform immaculate, his expression severe. Around him, German scientists and engineers worked on various components of aircraft oxygen systems, pressure suits, and other high-altitude equipment. "Show me the latest results," Krüger demanded of Dr. Reed. Ernst Schmidt, the civilian scientist heading the research department. Schmidt adjusted his glasses nervously as he led the officer to a testing chamber. "We've improved the formula for the oxygen-generating canisters," he explained, "but we're still experiencing failures in extended duration tests. The pilots must change canisters every 70 minutes to ensure safety, but in combat conditions..." Krüger cut him off with a dismissive gesture. "Our pilots are the finest in the world. They will follow protocols. What I need from you is increased production, not excuses." Schmidt hesitated, then spoke carefully. "Herr Oberstleutnant, I believe we should consider returning to the conventional oxygen systems until we can resolve these issues. We've received reports of at least 7 unexplained losses that may be attributed to the new system." Krüger's face hardened. "The Führer has personally approved this technology program. It allows our fighters to operate at altitudes the enemy cannot reach with their inferior equipment. You will solve the technical issues without questioning the strategic directive." Behind his professional composure, Schmidt felt a familiar chill of fear. Like many German scientists, he served the war effort out of a complex mixture of patriotism, coercion, and the pure intellectual challenge of solving difficult problems. But he also knew that failure could be interpreted as sabotage, and the consequences would be severe. "Of course, Herr Oberstleutnant," he replied. "We will double our efforts." At RAF Northolt, Squadron Leader James Blackwood gathered his pilots for the morning briefing. Maps of occupied Europe covered the walls, with flight paths and target areas marked in colored pencil. "Intelligence has provided new information about Luftwaffe high-altitude capabilities," Blackwood announced. "Derry fighters have been using an advanced oxygen system that lets them operate above 35,000 feet for extended periods. However," he paused for effect, "we now know this system has a critical flaw. After approximately 70 to 90 minutes of operation, their oxygen systems may begin to fail, potentially incapacitating the pilot." A murmur ran through the assembled men. "This means that if you can draw them into extended high-altitude combat, time will be on your side. Their system gives them an initial advantage, but becomes a deadly liability the longer they stay at altitude." Flight Lieutenant David Cooper raised his hand. "Sir, how reliable is this intelligence?" Blackwood nodded, acknowledging the fair question. "It comes from the eggheads at Farnborough. They've been testing captured equipment. The science is sound." He didn't mention the weeks of painstaking work by Harrington, Fleming, and their team, or the lives already lost to this invisible enemy. Such details weren't necessary for the operational briefing. What mattered was giving these men any edge that might help them survive. "Today's mission will take you over the Ruhr. Expect heavy fighter opposition, especially from high-altitude interceptors. Use this information to your advantage, but don't take unnecessary risks." "That's all, gentlemen." Dismissed. "Doctor." Margaret Fleming stood at the laboratory window, watching a formation of American B-17s passing overhead, silver against the blue spring sky, heading east toward Germany. Their contrails formed white lines that slowly dispersed in the high-altitude winds. Somewhere up there, the information she and Harrington had discovered was being put to use, potentially saving Allied lives. Yet she felt an unexpected pang of sympathy for the German pilots, young men not so different from their British counterparts, using equipment with a fatal flaw they knew nothing about. The science that had revealed the flaw in the German oxygen system was neutral, unconcerned with nationality or ideology, but its application in wartime was anything but neutral. "Penny for your thoughts," Harrington said, coming to stand beside her at the window. Fleming sighed. "I was just thinking about the German scientists who designed that system. They're probably still trying to figure out why their pilots are blacking out." Harrington nodded thoughtfully. "They'll solve it eventually. They're good scientists, but by then, it might be too late for them." "Do you ever wonder what it will be like after the war?" Fleming asked, "when scientists from all sides can share their research openly again?" Harrington smiled wryly. "If there's anything left to share. But yes, I do wonder. The advances we've made under pressure of war, not just in aviation medicine, but in radar, electronics, materials science, it's been extraordinary. Perhaps some good will come of it all in the end." Their conversation was interrupted by the arrival of Air Commodore Winters, the military officer, overseeing their research unit. "Excellent work, both of you," he said briskly. "The information you provided about the German oxygen system has already made a difference. Intelligence reports at least 3 confirmed incidents of Luftwaffe pilots becoming incapacitated during extended high-altitude engagements over the past week." He didn't need to elaborate on what incapacitated meant in the context of aerial combat. "There's something else," he continued. "We've captured a German scientist who was working on their oxygen systems. He's being brought here for debriefing. I'd like you both to participate." Hauptmann Karl Weber felt the familiar symptoms intensifying, a headache behind his eyes growing stronger, slight dizziness that made the horizon seem to tilt. He had been at high altitude for nearly 80 minutes, longer than usual, drawn into an extended chase of Allied bombers that had split from their main formation. Something was wrong with his oxygen. He checked the flow indicator again, still spinning as it should be, but the air in his mask tasted stale, and he found himself breathing harder, unable to get enough oxygen despite the system apparently working normally. Training took over. He pushed the control stick forward, beginning a descent to lower altitude where the air would be breathable without assistance. His vision began to narrow, darkness creeping in from the edges, a telltale sign of approaching unconsciousness. With the last of his focused awareness, Weber rolled the Bf-109 into a steeper dive, trading altitude for the safety of thicker air. At 15,000 feet, the symptoms began to recede. Weber gulped the richer air, his mind clearing as oxygen reached his brain. He had survived, but the mystery remained. The oxygen system had failed somehow, despite all indicators showing normal operation. He was alive only because he had recognized the symptoms in time and had the altitude to spare for a rapid descent. He knew that others hadn't been so fortunate. As he leveled off and set course for his base, Weber made a mental note to report the incident in detail. Something was wrong with the new oxygen systems, something the ground crews and the scientists needed to understand before more pilots were lost to this invisible killer. What he couldn't know was that far to the west, in an English laboratory, the answer had already been found. The chemical pellets designed to give Luftwaffe pilots their high-altitude advantage contained a fatal flaw. A flaw that was now being exploited by the enemy, turning a technological edge into a deadly liability. Dr. Ernst Schmidt sat nervously in the austere interrogation room at RAF Farnborough. He had been captured when his train was strafed during an Allied air attack 3 weeks earlier. As a civilian scientist, he had expected to be placed in a standard prisoner of war camp. Instead, once his identity and role in the Luftwaffe's high-altitude research program were discovered, he had been brought to this facility for specialized debriefing. The door opened and 2 civilians entered, a tall, thin man with a scholar's stoop and a dark-haired woman whose intelligent eyes assessed him carefully. Behind them came an RAF officer who introduced them as Dr. Harrington and Dr. Fleming. "Dr. Schmidt," Harrington began without preamble, "we've been studying the oxygen generation system you helped develop for the Luftwaffe. Particularly interesting is your use of potassium superoxide pellets with the modified chemical structure." Schmidt stiffened slightly but said nothing. "We've identified the flaw that causes carbon dioxide reabsorption after extended use," Fleming continued. "What we'd like to know is whether you were aware of this flaw, and if so, what steps were being taken to address it." Schmidt's shoulders slumped slightly. Scientific curiosity and professional pride momentarily overcame his reluctance to cooperate with the enemy. "We knew something was wrong," he admitted. "Pilots were reporting symptoms consistent with hypoxia or carbon dioxide poisoning, despite oxygen flow readings remaining normal. We had begun to suspect the pellets were breaking down, but we hadn't identified the precise mechanism." He looked up at the British scientists, professional respect evident despite the circumstances. "How did you solve it so quickly?" Fleming explained their testing methodology, and Schmidt nodded in understanding. We were under immense pressure to produce results, he said quietly. The High Command wanted a system that would allow our fighters to operate above the ceiling of Allied bombers. We knew the system wasn't perfected, but we were ordered to deploy it anyway. Harrington and Fleming exchanged glances. The story was a familiar one in wartime, scientific caution overruled by military necessity, with fatal consequences. As the technical debriefing continued, the scientists gradually moved from adversarial questioning to professional discussion. The war still raged outside, but within the confines of that room, three people who had dedicated their lives to scientific inquiry found common ground. The fundamental approach was sound, Harrington acknowledged. Using chemical oxygen generation rather than compressed gas provides significant weight savings and extended duration. Schmidt nodded. The concept came from our submarine research. U-boats use similar technology for emergency breathing apparatus. We thought we could adapt it for aircraft use, but the lower pressure and temperature conditions at high altitude created unforeseen complications. Fleming asked about other high-altitude equipment the Luftwaffe was developing: pressure suits, heated clothing, specialized instruments. Some questions Schmidt declined to answer, his sense of duty reasserting itself, but the conversation remained collegial, underscored by mutual respect. By July 1943, the information gleaned from the Farnborough research had been fully integrated into Allied air combat tactics. Fighter pilots were trained to recognize the time window when Luftwaffe oxygen systems would begin to fail, and to extend high-altitude engagements whenever possible. Bomber crews were briefed on optimal altitudes that would force German interceptors into the deadly zone, where their equipment became a liability rather than an advantage. The technical intelligence provided by Harrington and Fleming's team, combined with the information from Schmidt's debriefing, had given Allied air forces a crucial edge in the increasingly desperate battle for air superiority over Europe. The Germans, for their part, eventually identified the flaw in their system and began developing a modified version of the oxygen-generating canisters. But production difficulties, combined with the increasing devastation of German industry under Allied bombing, meant that the improved system never reached widespread deployment. In a fighter base near Berlin, Oberleutnant Hans Müller climbed into the cockpit of his Focke-Wulf FW-190D, the latest version of Germany's premier fighter aircraft. Unlike Weber and the other pilots who had been using the experimental chemical oxygen system, Müller's squadron had been equipped with the traditional compressed oxygen bottles. The Luftwaffe had quietly reverted to the older, more reliable technology for most of its fighter units, while continuing to develop an improved version of the chemical system that had promised so much but delivered disaster. The retreat from technological ambition was emblematic of Germany's larger situation. The initial advantages of superior engineering and innovation gradually eroded by resource constraints, production shortfalls, and the overwhelming material superiority of the Allied forces. As Müller fastened his oxygen mask and prepared for takeoff, he knew that his chances of returning from this mission were growing slimmer by the day. The skies above the Reich were increasingly dominated by Allied aircraft, and the technological edge the Luftwaffe had once enjoyed was fading like morning mist under the harsh light of strategic reality. Back in England, a specialized research unit at Farnborough had moved on to new challenges, analyzing captured German radar equipment, studying the metallurgical properties of enemy aircraft components, developing countermeasures to the latest Luftwaffe weapons. The work on the oxygen absorber pellets had been just one small victory in the ongoing scientific battle that paralleled the military conflict. For Harrington and Fleming, the satisfaction of solving the puzzle had been tempered by the knowledge of what their discovery meant: more dead German pilots, young men not so different from the British and American airmen they were working to protect. The moral complexity of their role in the war effort was something they rarely discussed but often contemplated in private moments. They had done their duty, used their scientific training to save Allied lives, but the human cost of that achievement was impossible to ignore, especially after meeting Schmidt and recognizing in him the same dedication to knowledge and understanding that drove their own work. Dr. Margaret Fleming stood once again at the laboratory window, watching aircraft contrails crisscross the autumn sky. It had been 6 months since their discovery about the German oxygen system, 6 months of continued work on other captured enemy equipment, 6 months of scientific detective work in service of the war effort. "They're transferring Schmidt to a regular POW camp tomorrow," Harrington said, joining her by the window. "The intelligence officers have gotten everything useful from him." Fleming nodded. "What do you think will happen to him after the war?" Harrington shrugged. "If he's lucky, He'll go back to civilian research. He's a good scientist. They stood in companionable silence, watching the aircraft overhead. We saved lives, Fleming said finally. Not just Allied lives, German pilots too, in a way. Once we exposed the flaw, they had to address it. Harrington smiled slightly. Cold comfort to those who died before we figured it out. But yes, I suppose we did. The discovery made by the British scientists at Farnborough would never make headlines. It would not be celebrated in victory parades or mentioned in official histories of the war. It was one small thread in the vast tapestry of scientific and technical intelligence that helped shape the outcome of the air war over Europe. But for the pilots who flew into combat day after day, whose lives hung on the reliability of their equipment and the failure of their enemies, it made a critical difference. In the thin, cold air above 30,000 feet, where the margin between life and death was measured in seconds of consciousness, the work of forgotten scientists like Harrington and Fleming helped tip the balance toward Allied victory. Their story is a reminder that war is fought not only by those who carry weapons, but also by those who wield knowledge, the quiet heroes whose battlefields were laboratories and whose victories were measured in problems solved and lives saved. The abandoned Drägerwerk facility in Lübeck stood silent in the spring of 1945, its windows shattered by bombing, its laboratories emptied of equipment. The war that had driven its frantic research was in its final days, the Third Reich collapsing under the combined weight of Allied armies advancing from east and west. In London, as victory celebrations began, Dr. William Harrington and Dr. Margaret Fleming packed up their laboratory at Farnborough, their wartime collaboration coming to its natural end. The specialized knowledge they had developed would soon be applied to peaceful pursuits. High-altitude research for commercial aviation, medical oxygen systems, space exploration. And somewhere in a prisoner of war camp, Dr. Ernst Schmidt awaited his release and the chance to rebuild a scientific career in a world forever changed by the conflict that had set them all against each other. The oxygen absorber pellets that had once meant the difference between life and death for pilots fighting in the thin air above Europe would be improved upon, the lessons learned from their flaws incorporated into new and better systems. This is how progress often comes in human history, through competition and cooperation, through the efforts of forgotten men and women whose names may not be recorded in history books, but whose work shapes the world nonetheless. The great aerial battles of World War II taught humanity many lessons, not least among them the understanding that our technological creations can contain hidden flaws that reveal themselves only in the extremes of combat. The British chemists who unraveled the mystery of the Luftwaffe's oxygen absorber pellets played their part in the vast scientific effort that helped win the war. Their story reminds us that victory often depends not only on courage and determination, but also on the patient work of those who seek to understand the world and its workings, even in the midst of history's most terrible conflicts. As we look back on these events from the vantage point of our own time, we might ask ourselves what lessons we have learned, what mysteries we have yet to solve, and what flaws in our own systems remain hidden, waiting to be revealed when we venture into new frontiers, whether in the skies above us or in the uncharted territories of human knowledge. For in war and in peace, the search for understanding continues, driven by the same curiosity and ingenuity that led those forgotten British chemists to their crucial discovery so many years ago.